Hello friends, my name is Nitin Kunal Reddy. Today I am going to explain about copper and its alloys. Copper is one of the oldest and most widely used non-ferrous metal in the industry. There are some properties of copper. Firstly, copper is soft, ductile and malleable. It can be forged, rolled or wire drawn. It can be worked in hot and cold conditions. They are very light in weight and having a pleasing color. They have an excellent corrosion to resistance. Copper has a high thermal conductivity and high electrical conductivity. They are non-magnetic in nature. Ease of fabrication and good mechanability. It can be polished, plated for pleasing appearance, and it can be easily alloyed with other metals. Melting point of copper is 1083 degrees Celsius. Density of copper is 8.93 into 10 power 3 kg per meter cube. Young's modulus E is equal to 122.5 GPa. Tensile strength is equal to 220 MPa. Hardness is equal to 80 into 50 Bhn. Bhn is nothing but Brinell's hardness number, and GPa is nothing but gigapascals, and MPa is nothing but megapascals. So they are the units. So nextly we are going to discuss about copper extraction. How is copper extracted? Copper is extracted from its ore called copper pyrites. They usually are found in Earth's core. So there are three steps for extraction copper from the copper pyrites. Firstly, the copper pyrites are crushed into powders so that it can be easily to extract copper. And the next one is concentration. In concentration, the powder is mixed with water and we filter it and we dry it and the air is blown through it. Next, roasting. Copper pyrites are combined with iron and sulfur. It becomes copper iron sulfide and mixed with silicon oxide and oxygen. Smelting and converters. Metallurgical processes to obtain pure copper from impurities. Electrolytic refining. Copper is extracted also by using electrolytic refining process. It is done from a solution called electrolyte comprised of sulfuric acid and copper sulfate. On passing the current to anode into the solution, pure copper is deposited on cathode. 99.95% copper is obtained. Applications of copper. There are some applications of copper. They are used in electrical conductors, power cables, telephone cables, computer network cables, PCBs, connectors. They are also used in heat exchangers and heat vessels, as they are a high thermal conductivity, so they are used in heat exchangers and heating vessels. Base coating on steel so that it can be easily heated. Various appliances where lightweight and with good corrosion resistance is required, making alloys of brass, bronze poisonous, used as germicides. They are also used in food, chemical industries, water tanks, vessels, tubes, jewelry applications. There are four types of alloys in copper. They are brass, bronze, gunmetal, cupro-nickel alloys. Brass consists of copper and zinc. Bronze consists of copper and zinc. Gunmetal consists of copper, Zn, Sn. Cupro-nickel consists of copper and alloy nickel. So firstly we are going to discuss about brass. In brass there are three types of alloys: alpha brass, beta brass, alpha beta brass. In alpha brass there is less than 20% of zinc. It is also known as red brass. And in beta brass 20 to 30% of zinc is existing and it is also known as yellow brass. In alpha beta brass 30 to 45% of zinc is existing. Alpha is nothing but high ductile, beta is nothing but increases strength. So first, alpha brass. There are four types of alpha brasses. The first one is red brass. It consists of 85% of copper, 15% to 20% of zinc. Property is they are soft and ductile and have high resistance to corrosion. Applications are electrical. They are used in electrical conductors, condensers, heat exchangers, and tubes. Gliding metals. It consists of 95% of copper and zinc 5%, and it has a very high strength. They are used to make coins, medals, tokens, plates, fuse cords. And the next one is low brass. It consists of 80% of copper and 20% of zinc. It has a high resistance to corrosion. They are used to make ornaments, thermostats, bellows, musical instruments, bushes. Commercial brass. Copper 90%. It consists of copper 90%, zinc 10%, excellent hot or cold working. Costume jewelry, rivets, screws jewelry, case boxes. And the next type of brass is beta brass. There are two types of beta brasses. The first one is yellow or commonly known as cartridge brass. It consists of 70% of copper, zinc 30%. It has a very good strength, high ductility, cold working properties. They are used to make radiator caps, highlight reflectors, lamp fixtures, cartridge cases, plumbing accessories, radiators, fins, rivets. Amberley brass. It consists of copper 70%, zinc 29%, Sn 1%, improved strength and corrosion resistance. They are used in condensers and heat exchangers. And the next one is alpha beta brass. It consists of 30 to 45% of zinc. There are four types of zinc alpha beta brasses, and the first one is Munz metal. It consists of 60% of copper and 40% of zinc. The property is they have a very high strength, excellent hot working. The applications are valves, condensers, tubes, nuts, bolts, utensils. And the next one is lead brass. It consists of 60% of copper, 38% of Zn, Pb, 2%. Property is they are easy machinability. The applications are keys, locks, lock parts, watch pair parts. And the next one is forging brass. It consists of copper 59%, 39% zinc, 2% Pb. They are suitable for work for hot working. Applications are plumbing parts. They are used to make plumbing parts like valves, taps, pumps, etc. Architectural brass. It consists of 57% of copper, Zn 40%, Pb 3% for forging. Decorative molding grills and locks. And the next type of the copper alloy is bronze. It consists of copper and Sn. So they possess superior mechanical properties and corrosion resistance. Strength increases with tin content. Tin maintained less than 12%, else be brittle. Bronze can be shaped into wires, red sheets, etc. There are four types of. Actually, there are six types. Six types of brasses. The bell bronze. First one is bell bronze. It consists of copper 78% and tin of 22%. They are very hard, brittle, possess resonance, making bells. Coinage bronze. 95 to 5% copper, 3% of zinc, 1.5% of Sn. Good strength and resistant to corrosion copper coins. Phosphorus bronze. It consists of 88% of copper, phosphorus 0.5%, tin 10%, zinc 1%, platinum 0.7%. A pH increases strength and ductility resistance to corrosion. Bearing pumps, parts, springs, screws, etc. Aluminium bronze. 89% of copper, 7% of aluminium, 3.5% of Fe, 0.35% of tin. Fe is added to increase strength, hardness, resistance to corrosion, cold working operations. Applications are gears, propellers, cams, rollers, tubes, etc. Manganese bronze. 50 to 60% of copper, 35% manganese, remaining Fe resistance to corrosion, hot working. Operation applications are blushes, plunger, feed, pumps, rods. Silicon bronze. 95% of copper, 3% of silicon, 1% of manganese, 1% of ferrous. Silicon is added to add strength, harden, and improve corrosion resistance. Applications are casting dies, rolling, forging, hot or cold pressing boilers, parts, etc. Gunmetal. It consists of copper, zinc, Zn. Zn acts as a deoxidizer, improves lucidity during casting. A small amount of lead can be added to improve castability and machinability. Admiralty gunmetal. It consists of 88% of copper, 10% of zinc, 2% of Resistance to corrosion producing casting. Pumps, valves, casting parts. Lead, gunmetal 85% of copper, tin 5%, Zn 5%, Pv 2%, and it has a very high strength. Applications of pressure tightening apparatus like boilers, steam pipe, fitting, hydraulic valves, gears. Cupronickel. They consist of 70% of copper, 30% of nickel. It can be hot or cold work. Good corrosion resistance in seawater applications, seawater penguins. Monal metal. Copper 29%, 68% and Ni 1.25% Fe, Mn resistance to corrosion, good mechanical properties. Chemical food, industries, tank, steam turbine blades. K-Monal 29% of copper, 66% of nickel, 2.755 aluminium, 0.5% of Mn, and titanium. Good mechanical properties, and applications are motors, ship propellers, blades. Thank you friends for listening my video. Thank you.